In this video, we'll talk about India's semiconductor dependency, the challenges we face for achieving self-sufficiency in the upcoming years. Every year, India consumes about 35 to 40 billion worth of semiconductors, and this number is expected to go up to 100 billion by 2030. The semiconductors we consume are found in smartphones, laptops, servers, and 5G equipment. They are used in telecom infrastructure, defense, and automotive sectors, and in the electric vehicles or the EVs. Also, they are used in industrial equipment and consumer electronics such as TVs, ACs, and smart appliances of that kind. Currently, India imports about 90 to 95% of its semiconductors. Only a small number of chips for defense and space applications are manufactured here. Some chip packaging and testing happens in India, but a sizable portion of global chip design is done here. However, while India contributes a lot to the design and back-end services in the semiconductor sector, fabrication or manufacturing of chips being used here is almost entirely done in Taiwan, Japan, South Korea, China, and United States, and hence they are all imported. So India's primary contribution to the semiconductor industry is mostly chip design. Major players such as Nvidia, Qualcomm, Intel, and AMD have large design centers in India where engineers design and verify the chips. However, India does not have commercial scale semiconductor fabrication plants or fabs. Since no large scale chip manufacturing happens here, nearly all the chips used in smartphones, laptops, EVs, and industrial equipment are imported. Taiwan is the largest supplier of chips, accounting for about 60% of India's chip imports, mainly through TSMC, the world's number one foundry or chip manufacturer. China mostly supplies low-end chips such as memory, display drivers, and power semiconductors. South Korea provides memory chips like DRAM and NAND flash primarily through Samsung and SK Hynix. United States is a major source of high-end AI GPUs, processors, and networking chips, and they are mostly imported from companies big names like Nvidia, Intel, and AMD. Out of 40 billion, about 17 to 20 billion is from smartphones and consumer electronics, while the automotive and EV sectors account for about 7 to 10 billion. These are in US dollars. So about 25 to 30 billion of India's semiconductor demand comes from consumer electronics, smartphones, and the automotive and EV sectors. India is increasingly concerned about its heavy reliance on semiconductor imports as it results in significant foreign currency outflow. Also, building domestic semiconductor manufacturing capabilities would help create high-skilled jobs, reduce dependence on imports, improve the trade deficit, enhance technological independence, and strengthen national security. We'll see how in the later slides. Some of the countries from which we import semiconductors like the Taiwan, China, and South Korea are experiencing geopolitical tensions. For example, China's ongoing military pressure on Taiwan raises concerns about stability of global semiconductor supply chains. Since Taiwan produces over 90% of the world's most advanced chips, any disruption could have a devastating effect on Indian economy and, of course, the global technology industry. Today, almost every industry, automobiles, telecom, healthcare, defense, they all rely on semiconductors. Just as oil shaped global geopolitics in the 20th century, semiconductors drive the world economy today. Countries that control semiconductor production hold significant economic and military advantages, as these chips are critical for defense, aerospace, and communication infrastructure. India's defense systems, space missions, and 5G networks require advanced semiconductors, most of which are currently imported. Additionally, countries that control semiconductor intellectual property, IP, like the US, can impose export restrictions on India. Although this has not yet occurred, it cannot be ruled out. The US has already banned China from accessing advanced AI chips and semiconductor manufacturing equipment, preventing ASML, the only supplier of extreme ultraviolet lithography machines or the EUV machines, from exporting to China. Self-sufficiency and technological independence in semiconductors must be a long-term national priority. Also, some imported chips come from sources with potential security risks, making them vulnerable to hidden backdoors or malware. This poses a national security threat, especially for defense systems. Rigorous testing and verification of imported chips must be a priority before they are integrated into the critical infrastructure for our country. If you have been with me so far, you may be interested in our flagship course on one of the sunrise sectors, which is semiconductors. When some of us hear the word semiconductors, we think too technical, not for me. But smart investors know this. Semiconductors are the new oil. From smartphones to AI, EVs to defense, cloud computing to modern healthcare, chips power everything today. Global investors who spotted this early made serious wealth from companies like Nvidia, TSMC, MediaTek, Qualcomm, SK Hynix, Samsung, and Applied Materials. These are big names now and have turned into multi-baggers over the last decade or so. Now here is the exciting part. India is entering this game right now. Government has a massive outlay of 10 billion US dollars for Semicon India program. That's easily the highest incentive announced for any sector here in India. Big players like the Tatas, Adanis, Vedanta, HCL, and some smaller ones too like CG Power, Keynes, Dixon are all eyeing this opportunity. They are setting up chip manufacturing, packaging, and design hubs. So we spent nearly 2 months researching and breaking down this complex industry, and then built this course that explains it all simply and clearly from an investor's angle. You learn how the chip manufacturing, packaging, and design industry works, where India fits in, which Indian and global stocks are worth tracking, and how to avoid the hype, manage the risks, and spot the real opportunity in this sector. Check the link to our course on semiconductors in the description or in the pinned comment below. Thank you. Okay, it's great that we want to change the current situation where we import 90 to 95% of our semiconductor needs. However, before making these changes, we must understand why this situation exists in the first place. Why do we even import so much from countries like Taiwan, China, South Korea, and the US? What challenges will we encounter if we attempt to change this situation where we manufacture these components ourselves locally? So let me go ahead and list the challenges here. First challenge is, of course, the high capital investment. Chip manufacturing is a highly complex undertaking that requires an investment of over 10 billion US dollars. A single fabrication plant similar to those operated by global giants would require upwards of 10 billion, even 15 to 20 billion US dollars. Because of this, we do not have commercial scale foundries here in India. Foundries like those built by Samsung in South Korea and TSMC in Taiwan do not exist in this region. The absence of commercial chip foundries in India implies nearly all the advanced chips used in smartphones, EVs, and telecom equipment must be imported. As I mentioned earlier, manufacturing a chip can involve over 1,400 intricate steps and can take anywhere from several weeks to 3 months to 4 months. It is highly complex process involving multi-billion dollar machinery that operate in a highly controlled environment with almost zero tolerance for defects and impurities. Even a microscopic particle of dust can render a semiconductor wafer defective, making the process one of the most sensitive in modern manufacturing. Third challenge to overcome in semiconductor manufacturing is the complex supply chain of chemicals and rare materials. In addition to being a capital intensive and complex process, semiconductor production requires high purity chemicals and rare materials, which involve a global supply chain spanning multiple countries including China, Australia, Japan, South Korea, and Africa. Anyone setting up a foundry here must be able to manage this complex supply chain efficiently and they should possess the expertise and experience to do so, or they just need to collaborate with someone who has the necessary experience. One of the biggest hurdles for India for manufacturing semiconductor chips is the limited R&D that we have done in advanced manufacturing. While we have made significant progress in chip design, we lack expertise in high-end semiconductor manufacturing. As I said earlier, it's a highly complex process requiring decades of research and precision engineering. Unlike Taiwan and South Korea, which have built a strong semiconductor R&D base, India is still in early stages of developing the expertise required for fabrication, for lithography, and process node enhancements. While these challenges exist, government is trying to make efforts to address these challenges. The government is working towards addressing these concerns, including providing capital investment support for semiconductor fabs, for managing the complexities of setting up foundries and chip manufacturing, to fix the necessary infrastructure. They are trying to address the supply chain risks and also trying to promote the R&D required to advance semiconductor manufacturing.